Welcome everybody. So today this is the second video that I'm recording to capture project 4 task 2, and let's get started. Now, as part of the servlet, let's firstly cover the 4 requirements that we need to on top of project 4 task 1 that we have added in task 2. Now the first requirement is logging useful information. Let's check the servlet that we've created, fetch recipe servlet, to see what kind of information we're logging. Now, like we saw previously in task 1, the API that we are hitting is fetch recipe. As part of that, we've initialized the model called cocktail recipe Mongo, which we'll see again very quickly. Let's check the doGet method and see what it essentially does. Now, as part of logging useful information, let's have a look at the request information that we're logging. As part of the request information that we're logging from the user when they use their mobile phone or any web application to hit our web application here, we see that the information that we're getting is the authentication scheme, the servlet path, whether the connection is secure or not, the browser details like the user agent information, and the IP. As we can see, we are fetching all of this information, adding it to a JSON object here, and inserting it into the MongoDB database that we have hosted on the cloud, which we will look at in a very short while. At the same time, what we also do is we actually hit the URL, which is the third-party API called the Cocktail DB. This is the API that we are hitting. It's not a banned API, and we hit it using the GET request method, and we get the result back, which is in the form of JSON string, and we convert that into a JSON object. We then make sure we do that below, but here this is the information that we have converted to a JSON object that we get from the user as part of the request. Now this is the JSON object that we create to get the relevant first cocktail JSON object that we have created here. Now this JSON object is created based on the data that we received from the API that we hit, and we had put it into string result, which has a JSON string. This string result JSON string is used to create the first cocktail JSON object, based on which we are forming the output that we'll show to the user, and the JSON output that we send back to the Android application. Now, as we can see, we are only creating the JSON out of the data that we actually need to send to Android, which is again name, the type of drink, recipe, and the timestamp. And only that is sent back to the user. As we can see, the response output is created based on this data and sent back to the Android application that requests for this data. Apart from that, we also use the response output to log the data into the database. As we can see, I'm also using the get current timestamp method, which I was able to get from Stack Overflow, and would like to thank the user that helped me get this. It's a neat little method that helps just create a string time-based current timestamp that would be helpful for the user as well as it is user viewable. Now, let's check requirement 2, which is storing the information onto a database. Let's first quickly have a look at the database, which will help us easily understand what I'm talking about. Now this is a MongoDB Atlas, and this is the NoSQL database that is hosted on the cloud. Now here we can see that cocktail recipes is the database name of the database that we're using to store the information, which has different collections like response, request, most common. Let's check out two of the most important collections that we'll be using. Now this is the request collection, and as we can check out one of the 20 documents that are here, it again has the information that I was showing you in the Java application: the path, browser and browser name, current timestamp, request secure, and machine IP information that we saw previously. So this also is just one of the 20 documents that we can see that has come from different testing that I have done. Like we can see, the browser information is Postman. When I was using Postman to hit the API, I also had used Dalvik 2.1, which was the simulation with Android Studio that I used to hit the API. And similarly, Mozilla Firefox, Mozilla 5 was again another way that I hit the API again. Similarly, we have the collection response, which shows relevant information here. As we can see, it has the information that we are sending back to the Android application, which is the type of drink, recipe, the name of the drink, and the current timestamp. Now let's go back and check out cocktail recipe mango, the model class that we're using to hit the database. Now let's check out the cocktail recipe Mongo constructor, which uses the connection string that we get from there that helps us connect to the database and get the database name called cocktail recipes. Now it has multiple methods like get request, which essentially does the same thing of getting the different details like authentication scheme, path, browser name, machine IP, and other such information for every document in the request collection. Similarly, the get response does the same thing, but for the response collection, and helps us get the response data, types of drink, recipe, name, and current timestamp. This it does for every document in the collection. And we use the get response as well as the previous get request method to populate the logging that we'll see on the dashboard. That helps us immensely. We will come to this a little later, but in a few minutes, but we'll also see the usage of methods like get total number of requests, get most recent cocktails, as well as get most search for cocktail, as we use all of those to create the analytics information, the operation on the operational dashboard. So we had previously used the insert request and insert response methods to actually populate the collections in the database. The request collection was the one where we actually input the JSON request we got from the user, and similarly for response, we used JSON response. Now, talking about task requirement 3, which is displaying operations analytics and full logs on a web-based dashboard. It has 3 parts. The first one is there should be a unique URL address with a web interface dashboard for the web service. Let's go and check the path for logging as well as analytics, the data that we are using. Here it is. So we have deployed it on Heroku, and this is the username of this is the URL for the Heroku app that is already deployed there. We are hitting /logs. So there are 2 different URLs as part of the dashboard. One is /logs and the other one is /analytics that helps us get the relevant details. First, let's just check out the /logs URL. Now this is the logs for cocktail recipes. Here are, which has the request as well as response logs. So these are the request logs for every request that was made. As you can see, it is neatly populated in a tabular format and does that for all the logs that we have. Similarly, we have response logs that get populated based on timestamp and all the information that is sent back to the user. Apart from this neat representation on the dashboard for logs, let's also check out the analytics path. Now, the analytics path represents the operations dashboard part where we show some analytics on top of it. The first analytical data that we are showing are the three most recently searched for cocktails. So the last three cocktails that we searched for were Sangria, Whiskey Sour, and Sangria again. In fact, let's quickly try to change and add a new one to see if this gets updated. Let's hit the same using maybe Postman. Okay, so let's check that out. And we say fetch recipe and name is equal to, we can try something like Long Island iced tea. And let's send a request. We get a response for types of drinks, recipe, and current timestamp name. Let's see if the analytics dashboard changed based on that. As we can see, the analytics dashboard also changed, and we get the three most recent cocktails for which the recipe was searched based on timestamp descending order. The second one is the most searched for cocktail. The most searched for cocktail has been mojito, which has been called 15 different times. And the third analytics data shown is the number of times our API is hit. This is a useful information as a lot of APIs have a limit. The API we're using does not right now have a limit, but it could in the future, and other APIs generally have a limit. And it's important to have an understanding of how many times the API has been hit. Now let's go back to the code once and see how this data comes. This data comes from get total number of requests, which helps us get the total number of requests as count from the database. For that, we are doing an aggregate query on the MongoDB database where we are trying to get the total number of count and returning that here. Similarly, we are also showing the most recent three cocktails. This has another query that we saw on the analytics dashboard. We are only limiting it to three, which shows the three most recent cocktails. And we get the name and timestamp information for the same, which we then later display on the analytics JSP page. As we can see, this is it. This is where we are displaying the name and the current timestamp and have created a table out of it. The second one was the most recent, most searched for drink, and that's what we show here. This is the most searched for drinks that we just saw here. And then this is most recent cocktails, also something that we already checked. So as we can see, the third requirement has also been fulfilled, which had three different parts. The first part was a unique URL should be available for the dashboard, which, like we saw, there were unique URLs /logs as well as /analytics that helped us get the dashboard information. The second one is that the dashboard displays at least three interesting operation analytics. We just saw three really important analytical information that we saw on the dashboard. And the third one was the dashboard displays formatted full logs. And as we saw, the data was formatted in a tabular format. Now, for the fourth requirement that the application should actually be deployed on Heroku, we saw that floating Oasis is the URL for the Heroku application that is deployed there. If you want to check, we can actually check the same here. We can check that if I log in using my ID, I'm able to see the same one, floating OSS. This is the floating OSS 02268 deployed application that we have been hitting here, floating OSS 02268. And using this, we've been able to run the application as well. So that was the fourth requirement, which says this web service should have the functionality of task one, but should also have logging, database, and dashboard analytics functions. And as we saw that it is deployed successfully on Heroku. Thank you very much, everyone. I'm now stopping the recording.